All right, hello. My name is Ryan Toy, and this is my Physics 2212 Lab 1 report. So first, a table of contents. The lab report will start with an introduction, follow with data and observations from the experiment, then with the code I used on the GlowScript portion of the experiment, and we'll offer a discussion on the results I found, and then finally we'll conclude with the what if questions. So, the introduction. Purpose and fundamental principles. The main purpose of this lab is to observe how neutral objects can hold charges and interact with each other. It demonstrates Coulomb's law of electric charge attraction and repulsion, and Newton's second law needs to be considered for the influence of gravity on the system. A quick preview of the results of this experiment showed that the positive charges that the tapes hold cause them to repel each other in the end. A quick refresh on Newton's second law. Newton's second law, known as the momentum principle, states that a force is equal to the change in momentum over the change in time. It indicates changes of movement within the system and the surroundings, and is given by F net equals delta P momentum over delta T time, and F net equals mass times acceleration. Coulomb's law states that magnitudes of charges influence the repulsion or attractive ability of the charges depending on the magnitude of the distance between the charges and the sign of those charges individually. If two charges are like in nature, they will repel, and if two charges are opposite in nature, they will attract. So here's my experimental model, with the top tape being the system and the bottom tape being the surroundings. The tape mass was measured to be 1.02 times 10 to the negative 4th kilograms. The length was 0.15 meters, and the width was 0.02 meters. The tape was distanced about 0.033 meters away from each other and showed slight repulsion when given induced charge. Here are my constants of code, as well as me defining the E-field equation in GlowScript. And the E-field on one piece of tape was found by comparing gravitational computations to electric field computations. Here's a model of the code that I used for the rest of the experiment, where the tape is modeled as a bunch of charges next to each other, so the force can be observed on every charge present. And some results. The magnitude of electric force that I found measured to be 8.91 times 10 to the negative 6th, and the magnitude of gravitational force I found measured to be 9.996 times 10 to the negative 4th. Some sources of error that I found were that the tape was not in a controlled environment, and therefore it could have lost charge due to interaction with the surroundings, like a human touch or a table. So, what if? If the protons became negative and electrons were positive, the observations made would not change, and the tapes would still repel each other because of like charges. The negatively charged protons would have just been lost instead of electrons. This is a concept that can be observed from the ending sign of an electric force calculation with two charges. Why does this matter? This is important to handle the tapes. It's important to handle the tapes as little as possible to avoid discharge of electricity that would prevent the neutral objects from interacting with each other. The charged tapes would lose their charges if handled too much, and would result in the experiment being weaker and sometimes even difficult to observe if it is handled too much. So thank you, and that's my lab report.